Okay, next topic is expanding and factoring. They both use something called the distributive property, which you may remember from middle school. If not, just hang out with me here, I'll tell you. Let me start with sort of a baby example, but it actually makes things easier in the long run. So here's what I got. Let's say I got a grocery bag here, okay? And let's say it's got, I don't know, 3 apples, and it's got 2 bananas in it. Okay, good. So if I ask you how many apples we have total, you would probably say 3. And if I said how many bananas, you would say 2. And you're right. Now, let's say I have 4 of these grocery bags. Now, how many apples do I have? Well, if I've got 4 bags and each have 3, can you tell you're going to have 12 apples total? And then how many bananas? Well, just like we did 4 times 3 here, can you tell I'm just going to say, well, you're going to have 2 bananas times the 4 bags, so total of 8 bananas. If you get it with grocery bags, you're going to be fine with when we do it with algebra, variables, and etc. So watch this. Let's say that I have 4, but this time instead of a grocery bag, let's say I have 3 x's, and then plus a 2 here, okay? You can do what's called expanding, okay? Expanding. And all you're doing is, hey, if you have 3 x's inside this little parentheses, but you got 4 of them, guess how many total x's you have? Not just 3, you're going to have a total of 12 x's. So that's what's right. And you got a 2 here, but you got 4 of them because there's 4 of these things. So guess what? To get that final number there, you're going to have an 8 there. 4 times 2 is an 8. Okay? You have just expanded, and it doesn't get much harder than that. I mean, sometimes you'll see negatives, like try this one. 5, let's go with 8x minus 6. If I tell you to expand that, just do the same thing. You got a grocery bag, 5 of them in this case, and you got the stuff inside. Same method though. You're going to have 5 times 8x, 40x. And then just be careful here. Don't think of this as a 6. Think of it with a sign in front. It's a negative 6. So 5 times a negative 6 is, watch this, negative 30. Just like that. Okay? Yeah, I think that's all for expanding. That's as complicated as it's going to get in our class. Now, if you go the other way, if you start here and try to work backwards to this, that's called factoring. And you'll see why in a second. So let me put one up here. Let's say that I gave you 24x plus, let's go with 16, okay? And I tell you to factor it. Well, I'll tell you right now, you should end up, just like with our grocery bag thing, okay? You'll have something outside the grocery bags, and you'll have 2 things inside it right now, because they're 2 terms. Hold on a sec.
Hunter Duff to the office, please. Hunter Duff.
Okay, so what number goes out front is the whole key. And I'm just going to tell you, it is the greatest common factor of these 2 terms. So this guy here has to be the greatest common factor. Now, if you've forgotten your whatever that is, 6th, 7th grade math, all that means is, what's the biggest number that goes into both of these? So you might be like, oh, 2. 2 goes into this and 2 goes into that. And you're not wrong. If a kid gave me a 2 there, I would not necessarily mark it wrong. I might give it a check minus, but the kid still knows what a factor is. But it's not the greatest common factor. So you might be like, oh, okay, oh wait, 4 goes into both of them. And I'm going to tell you, yes, you're right. And if you know how to do that, that's great. But it's not the greatest common factor. If you haven't seen it yet, the greatest common factor here is 8. So let me put that in. And then you just have to think, okay, I've got 8 grocery bags, and I know when I multiply by this, I get 24x. What does this have to be then? answer is 3x. And just check it out if you don't see it. 8 times 3, isn't that 24? So 8 times 3x would be 24x. And then, same thing for this guy. You got your 8 grocery bags, and you know when you multiply, this has to be 16. So what has to be over there? Are you getting 2? Because that's right. And that is called factoring. We've taken the expanded form, if you remember that word, and we have now factored it. And the reason they call it factoring is because you pull out the greatest common factor, okay? So if you do one, let's say, let me make one up. Let's go with 12 minus 20x. If I tell you to factor that, set up your frame if you want. You know what, like that's fine. I see kids do that all the time. Can I say one thing about this frame? This minus sign here, guess what that means? It's going to be in the middle here. The minus sign. But so your next move, what does that number have to be? A 2 will work, but a 4 is the greatest common factor. So I'm going to put a 4 out here, and then just think about what needs to go here and what needs to go there. You obviously can pause the video if you need some time to think. What I'm seeing is this. I need a 12 out front, so the only way I'm going to get that is if I have 4 times a 3. And then I need a 20x over here, and the only way I'm going to get that is if I have 4 times a negative 5x. So that is called, I didn't actually write it down. Going this way is called factoring. And when you go, so here, let me actually do that. If you go this way, it's called factoring. And then, let me erase these arrows so they're not as confusing. If you go from here to this way, that way is called expanding. And you'll hear both of those words used, okay? These two things, by the way, they're mathematically identical. They mean the exact same thing. It's just that sometimes it's more useful. Sometimes it's more useful to think about an expression in factored form, and sometimes it's more useful to think of it in expanded form.